Hey there, the following you're about to watch is a presentation that I gave at Passionate People. It's blockchain from zero to hero, and I will shut up now. Without further ado, enjoy. All right, let me have a quick sip of water. Welcome everybody. Let's talk about blockchain or whatever. I'm gonna try and explain it as simple as possible, and we'll see where we go. So, blockchain from zero to hero. All right, so this is me. This slide was not really properly updated. Yeah, I don't know. Oop, cursor. There we go. Let's put myself over here real quick. But this is me. Colors don't match, but that's fine. Whatever. I'm Luke. If you still haven't seen me around or at the office, you should drop by the office on Friday sometime. I'm usually there. I'm gonna try and explain blockchain from zero to hero, and it's gonna be fun. Hopefully. I'll try. All right. So blockchain, zero to hero, whatever. Here's the agenda. I'm going to start off with Git. Yes, that's a weird one, but hear me out. We're going to get there. Then we're going to actually talk about blockchain because why not? I'm going to ask for your money because I'm broke. Just kidding. We're going to talk about double spending and then about smart contracts. Yes, I'm going to try and explain smart contracts as well. We're going to get there. Bear with me here. All right. So as per usual, quick disclaimer. I am going to go very fast. This is a bit of a shorter presentation. Surprisingly, I managed to fit it into like a solid 10 minutes. So don't worry, you'll still have time to eat your lunch and not look at a weirdo on your screen trying to talk about blocks that are chained to each other. And yes, believe me, it's short because it's very simple. And obviously, as per usual, I'm going to plug my own website like 10 more times. So finally now, blockchain from zero to hero. Let's do this. I hope you all remember Git, which I hope you do. If you don't use Git and you use Mercurial or something else, then I would recommend seeking professional help. But Git is what we mostly use every day. Everybody hopefully does. It's version control, blah, 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 blah. But for simplicity's sake, just so I've reiterated, this is a Git repo, right? This is our lovely little Git repo. Right here, we've got all the cool things. I've got a finger to point this time, but I'm still going to drag myself around because it's funny, or at least I think it is funny. So this is a Git repo. It has multiple commits. Cool, or whatever. This is one of those commits. This is my friend Svemat. I was making a blog post on pull requests and merging strategies, and Svemat came in there, and I guess he stuck, so he's in all of my examples. I'm sorry, but here's my friend Svemat. Here's the commit message, and here's the hash. I hope we're all familiar with this at this point. If you don't know, the hash is a bit more of an obscure feature, but essentially every Git commit has a hash and a previous hash. And the hash is just a combination of all the information. So the changes that were made, the files that were edited, all that fun stuff, the name, the author, and the previous hash. So we know where it is in the chain. That all gets combined, hashed together, and then we get the hash. Sweet. So dissecting our Git commit is going to look like this. We have our Git commit again, introduce login button, the author, Svemat, because, you know, he wrote this. He didn't, but whatever. I said so. The hash, which is our lovely hash here, totally not a secret value. If you want to spot all the Easter eggs, I recommend you go through the presentation later again. Link to slides is at the end. The previous hash, which should be different, but ignore whatever, lazy presentation making, and the message. And obviously also the changes and all this other stuff. So we use the previous hash, like I just explained, to see where in the timeline it fits and all this other fun stuff, right? And this way we do branching, we do all sorts of cool stuff, tagging, a bunch of extra things. Obviously, there's a lot more to this, but this is the simple version. So that was Git. You're welcome. That's the end of my presentation. Pretty self-explanatory, right? No, I'm kidding. Obviously, this is a presentation about blockchain, and obviously there's pull requests, there's CI/CD, there's code review. I'm protected branches, much more. You get the gist. Get it? Okay, the gist of it. But this presentation was about blockchain, right? So let's talk about the blockchain. This is the blockchain. Why are those square? Wait. Hold on. There you go. Now they're round. Why is it? Hold on. 1 second. There we go. That looks a lot better. That seems very familiar, doesn't it? Okay. Wait. I get it. Get it. You see where this is heading? Get it? Because I changed the heading. No. Okay. So the blockchain is essentially like Git. There we go. Obviously, you know, we have our little repository or chain, if you will. This is a commit or block, if you will. This is, again, my friend Svemat. This is the message, sending 5 of whatever this is to me. And I mean, you get the gist, right? Does that ring a bell? Have we seen that 5 seconds ago on Git? Yeah. So let's dissect this thing, right? I made it a block this time because it is the blockchain, but same story goes. We have the author, Svemat, the hash, that thing, the previous hash, which should be a different value, but whatever. And we have the message, send 5 to Loosman Studies. Okay, block, commit, similar thing. So fine. Do we get somewhere here? It's the exact same to a certain extent. It's just that the blockchain is kind of like a very weird, peculiar Git repository. Okay? So instead of the blockchain being hosted on a central authority like GitHub or GitLab or Bitbucket, oh, I already cry pronouncing that name. Nightmares. So instead of it being stored on a centralized authority, like one of those websites I just mentioned, it is stored decentralized. The only real purpose of GitHub is to have the Git repository on my computer sync up with the Git repository on your computer. Same way that for blockchain, we said, you know what, we don't need a central authority. We can do this decentralized. So, you know, whatever, libp2p magic, computers communicating with each other, we call it consensus. I'm not going to get into it because it's a huge rabbit hole and every blockchain decides to do it slightly differently. Proof of work, proof of state, all these crazy things. I'm going to keep it super simple today. TLDR is that computers across the internet, libp2p, communicate P2P, point to point, and they together agree what the current state of our Git repository, blockchain is, right? So, fine. But Luke, why is this a weird Git repository? Because this repository has some rules. Just like your project might have some rules, like your sprint duration is 3 weeks, or you can only commit on Sundays because your, boss hates you. This one has some rules too. Okay, so let's start off with the first one. What's history is history. Essentially, what I'm trying to say with that is that anything that has happened in the past, anything behind this little arrow, right, not right now, is immutable. So no force pushes, no reverting pull requests, no rollbacks, no nothing. If you want to change something, add another commit to the top. This is how we end up with, I'm not going to throw any shades of specific names, but how we end up with 303,000 commits, right? If we can never, ever, ever clean up our Git repo, we add commits. But for the blockchain, magic, scaling, decentralized, infinite computing power, it doesn't really matter. We can be very long. But on GitHub, a 30,000 commit repo is already problematic, let alone 300. So whatever, state's immutable. Rule number 2, every X seconds, block time, seconds, minutes, microseconds, depending on the blockchain, we must approve a PR, okay? We must add a new commit to our history. For Bitcoin, this is 10 minutes, and I think if I have it correctly, for Ethereum, it's 14 seconds. So every 14 seconds, a new commit, or block, if you will, gets added to the Ethereum chain. So fine. Last but not least, rule number 3, the Genesis block. The Genesis block is like the initial commit. It's that one commit nobody can touch. For some reason, Gitkraken crashes if you don't have one, and it's what makes up the entire Git repository. I think in most Git repositories, probably none of you have ever tried, because why would you? But you can't edit the initial commit without completely making a new repository, because every commit afterwards, remember, has this previous hash thing, and then has that hash into its hash, which then has it in the next, and the next, and the next, and it just continues on. So if you change something in history, every block afterwards needs to be updated, which again, remember, rule number 1, we can't do that. So the Genesis block, the original, the first transaction, something had to happen. In blockchain's case, I was going to show a slide with a picture of it here, but whatever, they embedded a message in it of a news article, Satoshi Nakamoto, long story short. It's a whole fun Easter egg thing, and, there's some Bitcoin being burned, and some other weird stuff. This is besides the point. I understand that a lot of you are here trying to learn something, and I understand that people in the world like to make money. So the real question here is, am I rich yet? Let's do the depressing calculations. Note the word depressing. So in the same way that our Git repository stores files, right, as a list of modifications, like the history of modifications, added this line, removed this line, the blockchain stores our things data, numbers, value, our money, our assets as a history of changes, just like in Git, right? So let's have a look at our ledger, which is our fancy word for Luke put it in a table. Okay, don't worry, don't get scared. It's still this thing, but just in table format. Okay, so right here we still have the hash, we still have the previous hash. This time I put the effort to make them line up. Easter eggs. And as you can tell, this previous hash is this block's hash. This previous hash is this block's hash, right? So these are all lovely connected in a chain, and they're all in the same order. For the following purposes, I've added a few more people in here, and I've added a few more messages. So we can see all this fun stuff going down. Now, let's say we wanted to figure out how much money I have, because, you know, why not? Let's first go ahead and highlight every transaction here, if you will, or every block that includes me, because I'm selfish. So here's me, right? We have over here, we have me getting something. Here we have me spending something. Here we have me getting something and me getting something. Cool. I'm making money. Now, let's go ahead and put those numbers next to it. So for the top one, we see that Swemod is sending me 1 of whatever unit this is. So we can do +1. For the second one, we can see that right here, I'm sending Swemod 7. So he's kind of paying me back 1, but whatever. And then below that, we have Anthony sending me 5 and Swemod sending me 3. So let's put those numbers next to it. Right there, we have 1, 7. Oh, I need to sync this one up. There you go. 1, 7, 5, 3. Great. Cool. We're nothing with that. But these are our changes. You remember how we have like lines added, lines removed? Think of it like that, right? +1, -7, +5, +3. Add it all up together, sum it, whatever, and we get 2. Now, if this were 2 Ethereum, I would probably not be giving this talk. I would probably be in Timbuktu having a vacation. However, this is 2 of whatever unit I made up in our hypothetical blockchain. So great. Take all transactions, add the numbers together. That's how much balance you have. It's literally the same way that we clone a Git repository. It looks through all of the commits, and then obviously GitHub caches it, but that's besides the point. It looks through all of the commits, adds them all up together to get the final form, and that's what ends up on your computer. Those are the files your IDE ends up opening. Fine. So now that we've established that I'm broke, let's see how we can spend this non-existent money, right? Can I spend it is the question. And to be able to figure out if we can actually make a transaction, if the transaction is valid or not, we're going to do a very simple formula. Super easy. First, we're going to figure out whether what I have is more than what I want to spend. That seems pretty easy, right? We just figured out how to calculate what I have. Now we have the number of how much I want to spend. And if what I have is more or equal to what I want to spend, but transaction fees, so whatever, more than what I want to spend, right? If I have $10 and I want to spend 5, that is more, so we can spend it. It seems like kindergarten math. It is kindergarten math. It's just that instead of us doing it, the computer's going to do it for us. So how does this work blockchain-wise or Git chain-wise, if you will? Well, it's just a CI/CD pipeline right here. We have a check if can afford that does what we just did, looks through the entire Git history, checks all of our lovely commits, and goes, okay, Luke was given 5, Luke was spending 5, Luke was given 5, Luke whatever, and at the end it's 2. He's currently trying to send 1. Is 1 more than 2? Sorry, is 2 more than 1? I can't math. Yes. So we can spend it. Great. And then it approves the PR. If not, it denies the PR. So essentially what happens if any of the pipelines fail, it will crash, and then we will just not be accepting the PR. It will never get merged into master, and it's like it's never happened, right? So we can propose a transaction, and then the blockchain will tell us, great, we just made it happen for you. Or they will tell you, nope, sorry, transaction failed. And obviously, just like how it might take hours sometimes, depending on if you're using PHP or not, to deploy your CI/CD pipeline to a server, it can also take hours, depending on how busy the current blockchain is, right? The GitHub Actions runner, to run these pipelines. Okay, fine. We have a blockchain. It's party time. We've built a blockchain in Git. Congratulations. But I hear you thinking there were some other items on the agenda. So how about the NFT? Right? Where does that come from? Well, those are from smart contracts. Don't worry about it. Non-fungible tokens is just a thing that we made, another asset, a thing that you can't combine. So, 2 Bitcoin becomes 2 Bitcoin and it's a thing. And you can't add 2 NFTs. That's kind of weird. They're non-fungible. You can't, shove them together. It's not a value that goes up or down. It's 2 things you have, like a glass of water and a button to change the colors in your room. So what is this? Well, let's take the most popular example, Solidity, and let's put it in the perspective of another GitHub action. Because if we go back a few, guess what? Right here, I hid Solidity. Whoa, spoilers. Okay, so, find Solidity. Where does that come in? So essentially, Solidity is just another GitHub action that, say I wanted to buy the Duck NFT. I don't know, crazy example. Say I wanted to run the buy function on that. What would happen is I would put in my commit message, duck NFT, buy, 1, right? Easy peasy, lemon squeezy. Obviously, there's a bit more to it, but that's the simple version of it. The GitHub action will look at the commit message, see that we're talking about the duck NFT, figure out the file that was added in another commit for the duck NFT that the duck NFT author wrote, and then it will just run the buy function. And then enough GitHub runners will do that. Well, in this case, not GitHub, but enough miners will run that function. And as long as the majority says, yup, this pipeline completed successfully, this PR can be merged, the PR gets merged. Obviously, it's not called buy, it's called mint, but you get the point, right? We make a thing. So it runs another GitHub action, and then the GitHub action does its thing. And if the majority of the 50 times we ran that GitHub action, if at least 25 of them said, yep, we can approve this PR, then PR gets approved because democracy or whatever and decentralized consensus. Woohoo. Wow, I hear you say. Distributed Git. Sounds like we're back in the year 2000. So voila, that is the entirety of blockchain. That is pull requests. That is issues, that is CI/CD, that is smart contracts, whatever, Solidity, a little bit. That was blockchain from zero to hero by me. I'm your host, Luke. Again, hi. Thank you for listening. There will be a section for questions. Don't forget to check out the redesigned luke.show website because, yay, it's not a white page anymore. Slides can be found right here, luke.show/blockchain, or scanning the QR code. That was it. Are there any questions? Probably.